All right. We are going to now start moving into learning about the quadratic equation. This is another tool we have at our disposal to help us solve for solve quadratics, right? And the equation itself is arguably it's it's one of those things where it's super useful, and it's a great tool, but it's probably one of the most hated formulas in math legend, which is unfortunate because it's actually super useful. The thing about the quadratic equation is, without getting into it, it is derived from completing the square. So it's some of the stuff. If you do a little manipulating, I have a video where I show you where it comes from, right? Where they came up with it. So it's so you're going to see some things that you're kind of like, oh yeah, right? And then it uses a bunch of computation that we've been talking more and more about lately, like square roots and all of that. So what we're going to talk about, though, before we do a full launch into the quadratic equation, is we're going to talk about something called the discriminant, right? And so the discriminant, so that's this right here, that's how you say it, discriminant, is part of the quadratic equation that has the predictive power to tell us the nature of how many solutions and what they're going to look like. And it's pretty cool because if you just do the discriminants, you can usually you can find out some really good information about the parabola, right? So I think that I think it's worth learning, and it's kind of important, and all of that. And so what we're going to do now, all right, is we are going to so what we're going to be doing is actually analyzing it. So we'll put some numbers in, and then we'll look at the nature of the result we get, and then we will analyze that to determine the number and type of solutions the quadratic equation has. And yeah, so let's just kind of get started here, all right? So the discriminant, all right? So when you have an equation, right, I'm going to move this over a little bit. When you have an equation, right, the discriminant uses, our A, our B, and our C, and the whole quadratic equation uses all of that, right? And we're gonna pull our values off that standard form of the of a quadratic, right? So if it's not written in that form, the very first thing we have to always make sure we do is we always got to write it like that. So we want everything so it's set equal to 0, and then everything else is on one side, and then put it in standard form. So you've got your x squared term first, and then your x term, and then your constant, right? And so so the discriminant is this b squared minus 4ac, okay? Now, just really quick to kind of unpack this, what b squared means, all right? I'm just going to go through this piece by piece. So we're looking at this right now. So what b squared means is it means b times b, right? Remember exponents, right? So if I had like x times x times x times x, right? That's x to the fourth, and that's what the exponent means, is how many times are you repeating that factor, right? So b squared, when you see that, that means that you're multiplying b times itself, basically. And you're getting that b from the equation from right there before the x term. And so that's the first thing. And then you would subtract this 4ac term. And the 4ac term is the same thing as saying 4 times a times c, or you could think of it as 4ac. And so what's great about this doing the discriminant in the formula is basically you're just kind of dropping things into place, doing a little multiplying, and then doing a subtraction problem, and you're done. All right. Now, if you look at these pictures here, right, what these are showing you is an example where the discriminant, which is b squared minus 4ac, is greater than 0, right? So the result of the discriminant is bigger than 0. You have a situation where that is equal to 0, and then you have a situation where it's less than 0, right? So in other words, it's negative, right? What do you do when it's negative? This is when it's positive, and this last one is just when it's 0, right? So when this is positive, right, what you have is you have two real solutions, right? You have two real solutions, okay? Because you can see here it goes through graph twice, right? Another example of it would be if you had something like this, right? That would also have two real solutions. It would have that and that, right? So that will take care of a lot of examples, right, that we will deal with. And the next case is when this term, this b squared minus 4ac, is equal to 0. And when that happens, it basically sits and it perches on the axis, right? So it doesn't cross it. And so what we call that is we call that one real solution. Even though it's technically a double root, right? So you get the same thing twice, we treat it like one solution because in reality it's crosses in one spot, right? So there's one solution. So one real solution, you can see that gives you a real number. And then this last case, if you look at this, it never crosses the x-axis, right? Does not cross the x-axis. And if it does not cross the x-axis, that's where we're going to get into those complex numbers, right? And it's going to always give you two complex solutions, right? And remember, complex is a combination of a real and an imaginary, right? Real and imaginary numbers, usually adding or subtracting together. And that's what a complex number is. Okay, and we sort of talked about that a little bit when we went over complex numbers, but that's kind of the main gist of it, all right? And so this is what we're going to be looking at, and starting in the next video, we're going to do a couple of these, and we're going to see, okay, we'll put our numbers in, we'll see, is it greater than 0, is it equal to 0, or is it less than 0, and then that's going to tell you, without having to graph this or do anything else or finish solving it, that's going to tell you how many solutions you have and the nature of them. All right, so that's going to be the purpose. That's the intro. Next video, we'll start doing these.